This lesson is on the reciprocal function. The reciprocal function is the reciprocal of x, which is 1 over x. So this is the basic form of this function, but you can translate it and change it in many different ways, like by multiplying it by a negative or by a number, or adding something to its denominator. So you can change the graph quite a bit, but let's just look at what this basic format looks like. So to graph anything that's nonlinear, you want to find a whole bunch of points. Not just a few points, but a lot of points. So let's take a look at some points that you might want to try. But before we do that, let's talk about the domain. The domain is asking us what possible x values do we have to put in. Well, in this case, our denominator cannot be 0, so x cannot be 0. So that restricts our domain so that nothing at 0 exists. So if I put in x equals 0, I don't actually have a point. It does not exist. So hey, that's an interesting point to look at. Let's see what happens as x gets close to 0 so we can see what's going on in that area, because that's an area of interest. So let's take a look. What if x is 1? Well, 1 over 1 is 1. So that's a point there. What if x is 0.5? Well, 1 over 0.5 is 2. What if x is 0.25? Well, 1 over 0.25 is 4. So what do you think is happening? What if x is 0.001? Well, 1 over 0.001 is 1,000. 0.000001 is going to get even bigger. So you can see that as x approaches 0 from the positive side, f of x is actually going towards infinity, isn't it? But it's never going to cross that 0 line, will it? Because you cannot take something, put it in here, and get a negative number as the output. So this goes to show that if you have 1 over a really, 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 really small number, you actually get a really, really, really big number. Okay, what about the other side? How does it approach from the other end? So to approach it from the other end, we'd want to start at -1. Well, 1 over -1 is still -1. What about -0.5? Well, 1 over -0.5 is -2. It's almost a mirror image, isn't it? -0.25. Well, that's -4. And you can tell as x gets close to 0 from the left side, f of x gets closer to -infinity, doesn't it? So there's this sort of boundary here, and a lot of people will draw a dotted line, and this line is called an asymptote. In this case, it's a vertical asymptote because it's vertical, and it's very related to the domain because the vertical asymptote exists wherever the domain has a problem. So you'll see that the vertical asymptote is actually x equals 0. But we're not finished. We haven't looked at what happens as x gets really big or as x gets really small. So this might give us a sense of the horizontal asymptote. So let's look at what happens as x gets really big. Well, you can plug in these numbers here. What happens when x is 2? Well, if x is 2, then your answer is 1/2, which is 0.5. If x is 3, it's 1/3. X is 4, it's 1/4. So you can see that it actually gets closer and closer. So if you had, say, 1 over 1,000, well, that's really small. but it still doesn't cross over to become a negative number. It just stays really small and close to 0. But does it ever hit 0? Does it ever touch? Well, let's just hypothetically say we had a really big number like 100,000. Well, what would 1 over 100,000 be? Well, it'd be a very small decimal, right? So you'd have 1 and then 6 places back. Tiny, but it's not hitting 0. So there is actually no way of hitting 0. So that causes an asymptote just there, right? It's getting closer and closer to 0, but never touches. Let's see if that happens to the negatives. So to write this phenomenon, this asymptote, you could say that as x reaches positive infinity, f of x goes to 0 from the positive side. Now let's look at as x goes towards negative infinity, f of x goes towards what? Well, just turn your numbers into negatives and you'll see that it's a mirror image. Half, third, quarter, a fifth, and so on. So again, we have this horizontal asymptote of y equals 0 because y does never ever equal 0 in this case. There's no way to take 1 over a number and get 0, is there? So here is our general graph of 1 over x. Now, if you multiplied this by a negative, it would flip around and have the other parts. If you multiplied it by 2, you'd get some sort of expansion. If you, say, maybe added something here, then maybe it would rise. So there's a bunch of different things that you can do, but this is the core. So let's look at another example. 1 over x plus 2, what happens here? Well, you can plug in a bunch of numbers and find that the point of interest is where the domain has a problem. And the domain has a problem when x is negative 2, right? X cannot equal negative 2. So it's highly likely, in fact, it's for sure, that there's an asymptote, a vertical asymptote, at x equals negative 2. Now, what does that mean? Well, that means that as we get closer and closer to this point, we're going to get more and more to the infinities. Now, you can find a bunch of points, and you'll find that this will actually be the exact same graph as we had in the previous part, but it will be shifted over by 2 to the left. Now, what if you had a negative here? Well, all these points would be negative. So if there was a negative here, this would look like more like this. So that's giving you some intuition. Let's take a look at a few more transformations on a graphing calculator that you can find online or on your graphing calculator. So here's our 1 over x graph. There it is. Very good. What if we had multiplied that by 2? 2 over x. Well, all our numbers doubled. What if we made it multiplied by a negative number? So let's say negative 3 over x. Oh, look, it flipped. So what if you change something inside of the x? So 1 over x plus 2. So notice that shifted, right? Let's get rid of some of these expansions. So if you multiply it, it just changes, but the axes are the same. But if you add something to your x, your one asymptote actually shifts a bit, doesn't it? So let's just see, what if you had 1 over x minus 3? What do you think would happen? Well, there you go. It shifts over to the right by 3. Now, how do you think you could make it move up? So far, all of them have had a horizontal asymptote of 0. Well, we could take any of these functions, say go back to the first one and add 2. Look at that, it moved up by 2. Or add 3, moved up by 3. So if you had, say, 1 over x plus 2, which shifts left by 2, and then down by 2. Okay, so if we compare it to the original, which is the blue, that's the core, and here we shifted left 2 and then down 2, you'll see that the axes have actually shifted down 2 and left 2. So there's a few things you can do. This website is www.desmos.com/calculator, but you can find many different calculators to help you get a sense of how these graphs change according to how the formula is changed.